Hello everyone, this is Kevin Spargo from K-Sounds. In this video, we are going to build a trumpet sound from scratch using the Korg Kronos HD-1 engine. The first thing we'll need to do is load the entire EXS3 brass and woodwind sample set. Only part of EXS3 is loaded by default, and I'm going to use a sample that is not in the factory preload. Let's go to Disk Mode, touch the Factory folder, and touch Open. Now, touch the EXS Extras folder and touch Open. The file we need to load is EXS3 brasswoodwinds.ksc, so let's touch that and then touch Load. I want to keep all of my current sample data loaded, so I'm going to choose Append as the KSC allocation. Now touch OK. Let's tell the Kronos to automatically load EXS3 every time we turn it on. That way, the sound we create today will be ready to play next time, not missing some of its samples. Press the Global Mode button, go to the Basic page, then touch the KSC Auto Load subpage. Put a check in the box next to EXS3 brasswoodwinds.ksc. Now the Kronos will automatically load this entire sample set each time you power it on. Alright, let's get started creating a trumpet sound. Press the Program Mode button and select an initialized HD-1 program. Go to the oscillator/pitch page, then the OS1 basic subpage. Multisample 1 is assigned to the first multisample in the ROM bank by default. Let's choose the EXS3 Brass and Woodwinds monobank and then select multisample 116, Trumpet 2 mezzo forte. Now, I love being able to play legato phrases when I'm working with a solo instrument sound, and many of the Kronos samples let you do just that when set to play monophonically. Let's go to the Basic Vector page and then the Program Basic page. Here, we can change the voice assign mode from poly to mono. Listen to the difference. I'm going to hold down middle C and then press D several times. Here's how that sounds when poly is selected. Here's how that sounds when mono is selected. Before we continue editing, we should save our sound. Touch the Page menu and then write Program. For the category, choose Brass. For the subcategory, choose Solo. Then let's name our sound. I'm going to call this KS Trumpet. Touch OK and OK. Now let's begin to make the sound responsive. We will use the low-pass filter, so go to the Filter page and then the Filter 1 subpage. First, let's select Single as the Filter 1 routing. This will give us a single 12 dB filter, which is less aggressive than the 24 dB filter that was selected by default. The filter type should be low-pass, so we do not need to change the default setting there. Let's lower the filter cutoff frequency to set a baseline tone. As we play middle C, what we are listening for is the tone we will want to hear when we play very softly. The value of 46 sounds about right. So far, the filter cutoff is the same no matter what note you play. This means high notes end up sounding a little softer than lower notes because more of their overtones will fall in the range of what the filter is attenuating. That's not what we want. Right now, our trumpet should sound like it's being played at the same dynamic level no matter what notes we play. So let's go to the Filter 1 mod subpage and adjust keyboard tracking. Keyboard tracking is a controller that sends different values depending on what notes you play. A common setting for keyboard tracking is what we see by default. Notes below middle C yield progressively lower values. Notes above middle C yield progressively higher values. Middle C itself is the center, so keyboard tracking does not affect it. Since middle C is essentially immune to keyboard tracking with the default settings, middle C is the ideal note to use in initially setting the filter frequency. After we get the tone we want from middle C, we set the keyboard tracking so that the other notes match its brightness. Let's work with the parameter intensity to A. This tells the Kronos the extent to which keyboard tracking should influence the filter cutoff frequency. I'm going to play 2 octaves above middle C. Listen as the tone becomes brighter as we increase the intensity parameter. Now I will play different notes while adjusting the intensity parameter until it sounds like all notes have the same brightness. "15 seems about right. So far, we've programmed the soft dynamic and adjusted it so that every note has the same brightness. Now let's set the loud dynamic. We will use the filter envelope to brighten the sound, so let's look at the filter EG area of the screen. Intensity to A controls how much the filter envelope will brighten the sound. Let's set it to 40. Now when we play a note, the sound starts out much brighter, but then softens to the tone we had a moment ago. To see why that's happening, let's go to the Filter 1 EG subpage. The filter starts at 0, but it immediately jumps to a high attack value and then decays to 0 in a time of 70. Let's modify things a bit. We will set the start level to 99 and the attack time to 37. The attack level will be 90, so the envelope will move from a level of 99 to 90 in the time of 37. Now let's set the decay time to 85. This means that after the attack time of 37, the envelope will move from a level of 90 to a level of 0 in the time of 85. Let's hear how all of this sounds. As we can hear, the sound starts bright and softens, but compared to the original envelope settings, it stays bright longer and takes more time to become soft. Check out the graphic representation of the envelope at the top of the screen. When I press the Compare button, you can see the default envelope decays more quickly. I like our new envelope. The way the sound slowly changes dynamics will be useful in a lot of contexts. So far, the sound is always the same regardless of how forcefully or softly I play the keyboard. We need to add velocity response. Let's go back to the Filter 1 mod subpage. Remember the filter envelope's intensity to A parameter? It let us hear exactly what the filter envelope was doing to the sound, but it didn't give velocity control. For that, we need to use the velocity to A parameter instead. Let's set velocity to A to 40 instead of intensity to A. Now, the more forcefully I play, the more the filter envelope will brighten the sound. Before we leave this page, I want to set one more thing. It's great that the envelope gradually makes the sound less bright, but I'd like the option to make the sound brighter in the middle of a note if that's what the music needs. For that, I'll use the joystick. Filter A modulation will let us directly modulate the filter. For AMS1, let's choose JS plus Y as the source. Intensity controls how much the modulation source will change the filter. To set it, I'm going to press the joystick forward and hold a note while increasing the intensity. This lets me hear the maximum effect the joystick will have on the sound. "17 sounds about right. Check out how this can be used. I'm going to let a note decay and then use the joystick to brighten the sound again. Now is a great time to save our progress. Let's press the Record Write button. The Kronos shows the Update Program dialog box, asking if we are sure we want to save the sound at its current location. Let's touch OK. Next, let's give the sound more velocity response. So far, we've set the filter to respond to velocity, giving us touch control over brightness. Let's add velocity control over amplitude. Go to the Amp EQ page and the Amp1 Mod subpage. The parameter we're looking for is in the amp modulation area. It's called velocity intensity. First, I'll demonstrate the sound with this set to 99. The dynamic range is too great. When I play softly, it's hard to hear the notes at all. What we want is a happy medium between no dynamic range and the maximum dynamic range. Let's try a setting of 45. Here's how that sounds. Much better. Our sound is starting to come together. Let's make it even more expressive by adding vibrato. Go to the oscillator pitch page and the os1 pitch subpage. We're going to use LFO1 to add vibrato. First, let's set the LFO the way we like it. Then we will assign a controller to modulate it. Under LFO1, let's set intensity to 0.10. Listen to how that sounds. Good pitch fluctuation, but a little fast. Let's slow it down a bit. Go to the LFO page and the oscillator 1 LFO1 subpage. We're going to hold a note and lower the frequency setting until it sounds better. Now let's assign aftertouch to control the intensity of the vibrato. Go back to the oscillator pitch page and the os1 pitch subpage. For LFO1, we see that aftertouch is already selected by default for the AMS controller. We're going to set its intensity to 0.10 and set the original LFO intensity back to 0. This way, we will only hear vibrato when we use aftertouch. It's common for a real trumpet player's vibrato to increase in speed as it gets more pronounced. We can emulate that by assigning the LFO speed to respond to aftertouch. Let's go back to the LFO page and then oscillator 1 LFO subpage. We know we want the LFO's fastest rate to be 62, but we need to figure out what its slowest rate should be. Let's try different values for frequency as we hold a note and use aftertouch. I think 57 works for the slow speed. The difference between 57 and 62 is 5, so we will use aftertouch to gradually increase the LFO rate by 5. In the frequency modulation area, set AMS1 to aftertouch. Set its intensity to 5. Let's listen. So far, the LFO is only modulating pitch. Let's make the vibrato a little more pronounced by having the LFO modulate amplitude as well. Go to the Amp EQ page and the Amp1 Mod subpage. In the LFO 1 and 2 area, set the AMS modulation source to aftertouch. Now let's hold a note, press aftertouch, and increase the intensity setting until we like what we hear. Five sounds nice. Now we have a solo trumpet that responds to velocity, offers vibrato, plays legato phrases convincingly, and lets us crescendo in the middle of a note. Let's save our work. Press the Record Write button, then touch OK. Next, let's adjust the overall tone with a little EQ. Go to the Amp EQ page and then the EQ subpage. I want to reduce the low mids a bit to give the sound a little more clarity. Let's set the mid cutoff to 450 and then play some notes as we reduce the mid gain. -4 sounds about right. Let's compare with the original tone using the bypass function. Nice. I think it's time to add a little reverb. Let's go to the MFX TFX page in the routing subpage. I'm going to turn on MFX2 and select effect number 100, Overb. Then I'll set its return to 127 so we can hear the effect. That's a nice hall reverb, but I'd like the sound of a smaller space such as a room. Let's go to the MFX2 subpage. And let's select the Thick Room preset. Notice that a real-time control is already assigned. Knob 8 will increase the amount of reverb you hear if you turn it to the right, and it will decrease the reverb as you turn it to the left. All the way left will silence the reverb altogether. To hear that, we need to change the overall setting of the control surface. To the left of the 8 sliders is a column of 5 control assign buttons. Press the one labeled RT knobs/Karma. Now we can play notes while moving knob 8 to hear the amount of reverb change. Let's save our work. Press the Record Write button, then touch OK. So far, we've created a very playable basic solo trumpet sound. Now it's time to add some advanced programming that will take this sound to the next level. First, let's add some velocity switching. I'd like the sound to play normally most of the time, but when I play forcefully, I want to hear a fall instead of a normal note. Go to the oscillator pitch page, then the OS1 basic subpage. An HD-1 program allows us to have up to 8 velocity zones. Zones that appear higher on the screen will be triggered by higher velocities than those below them. In this sound, we will use 2 velocity zones. The normal samples we've been hearing will be triggered by lower velocities than the fall samples, so we need to move the normal samples down to the next zone to make room for the fall samples above them. For multi-sample 2, let's change it from off to multi. Then select the EXS3 monobank. We know we want the Trumpet 2 mezzo forte multisample, so type 116 on the numeric keypad and press enter. We want zone 1 to be triggered only when we play forcefully, so let's change its bottom velocity to 110. You can set this number differently if you like, any value from 1 to 127. The higher the number, the harder you will have to play to trigger the zone 1 multisample. If you are not sure which number to choose, you can hold the enter button while playing a note on the keyboard. The Kronos will use the velocity you play as the bottom velocity for the zone. Now let's choose a fall sample for zone 1. Number 137, cornet fall, sounds like a good match, so let's use that one. Let's listen to the sound now. It should sound normally until I play forcefully. Then we should hear a fall. Next, let's work with the joystick controller. Normally, the x-axis bends the pitch up or down by 2 semitones, or a whole step. With a solo trumpet sound, it can be useful to bend the pitch up by 3 semitones when playing lead parts. We are already on the oscillator pitch page. Let's go to the oscillator 1 pitch subpage. The pitch area at the top of the screen lets us modulate pitch directly. For JS plus X, let's change the value from 2 to 3. Now listen as I play a phrase with pitch bend at the end. Let's save our work. Press the Record Write button, then touch OK. While we are on this page, let's do another fun trick with pitch. This time, we will use the pitch envelope to create a fast upward bend into the note we play. When we release the key, we will hear a fast downward pitch bend, sometimes called a kiss. We will want to control when these musical gestures happen, so we will assign a switch to turn them on and off. The key to all of this is the pitch envelope generator, so let's look at the pitch EG area and set intensity to 3.20. Now go to the pitch EG subpage. Here's what the default envelope sounds like. Right now, the beginning of the note starts too low. Let's change the start level from -99 to -68. Now let's work with release. Set the release level to -99 and the release time to 11. I want to hear more of the kiss at the end, but the amplitude dies away too quickly. Let's change the amp envelope to fix that. Go to the amp EQ page and the amp1 EG subpage. Listen as we change the release time from 17 to 21. Now that the envelopes are set how we want them, let's assign switch 2 to turn these musical gestures on and off. Go back to the oscillator pitch page and the oscillator 1 pitch subpage. In the pitch EG area, change intensity back to 0. Next, change the AMS to switch 2 and set the AMS intensity to 3.20. Right now, switch 2 toggles on and off. It would be helpful if it were momentary, so these pitch bends would only happen while we are pressing the switch. Let's go to the basic vector page and the controllers subpage. Set switch 2 to momentary. Let's test the control. Our trumpet sound is now very flexible and musical. Wouldn't it be great if we could keep all of this versatility and add a mute that we could use at will? Let's do it. Go to the IFX page and the routing subpage. Route all oscillators to IFX1. Go to the Insert Effects subpage. Turn on IFX1 and select effect number 54, Biphasor. This is going to let us create a couple of resonant frequencies that will sound like a mute when we are done. Go to the IFX 1 through 12 subpage. On the left side of the screen, be sure the IFX1 tab is active. Right now, the effect sounds like this. There's a lot of unwanted motion. That motion is being created by LFOs. Let's take them out of the equation. In the Phasor 1 area, set LFO1 depth to 0. In the Phasor 2 area, set LFO2 depth to 0. Phasor 1 is going to provide the warm component of the sound, similar to a wah effect, except that it's going to be static. We want to hear the resonance of Phasor 1 by itself so we can set it properly, so set Phasor 2's output level to 0 for now. Let's make Phasor 1 more resonant. Set its resonance to 86. Now, let's select the manual parameter and sweep its value as we play until it sounds right. "52 sounds good to me. Now we will use Phasor 2 to provide a little metallic edge to the sound. Set Phasor 2's output level back to 100. Let's set Phasor 2's resonance to 86, select its manual parameter, and play notes as we change its value. I like 72. Great, we have a mute. Now we just need to assign a switch to turn the mute on and off. The effect is currently set to 50% wet. We will set it to be completely dry, letting switch 1 make it 50% wet when it's on. Let's set the effects output to dry. For the source, let's find switch 1 mod. Set its amount to 50. Now let's play some notes as we turn switch 1 on and off to test. Our final addition to this sound will be a plunger wah. Like our other controls, we will program this so that we can use it at will. Let's go to the Insert Effects subpage. To the right of the biphasor effect, the Chain 2 parameter should be set to IFX2. Now check the box beside it. This routes the output of our mute into the effect we choose next. Let's turn on IFX2 and select effect number 19, Stereo Multimode Filter. Go to the IFX 1 through 12 subpage. We want to work with the IFX2 tab on the left side of the screen. It should already be selected because we were working with IFX2 on the previous page. Like the biphasor effect, this effect has LFO motion by default. We don't want an LFO to modulate the filter, so set depth to 0. Most of the time, trumpet music will not need a wah effect, so we want its default setting to be transparent. Let's set cutoff frequency to 78. This will allow almost all of the original signal to pass through. To control the wah, we will use the joystick -y axis. Directly below cutoff frequency, set source to JS-Y and amount to -74. Now the joystick lowers the cutoff frequency, but it doesn't sound very realistic because there's too much resonance as the sound brightens. Let's set resonance to 23. Directly below resonance, set source to JS-Y and amount to 27. Now the sound will initially be less resonant, but resonance will increase as the joystick lowers the cutoff. We're done. Let's save our work. Press the Record Write button, then touch OK. Now let's enjoy our new sound.